equal to that angle. We are using the principle of what? Alternate angles are equal. They are equal. This is a segment, and that will be another segment. So the one opposite to that angle in that segment are equal. Take note of that. So the next property, good, cyclic quadrilateral. Cyclic quadrilateral. You know, a circle, the internal angles of a circle sum up to what? 360 degrees. You know this 90, 90, 90, 90, 90 times 4 will give you 360. 4, 9, 36, right? Add your 0, 360 degrees. So the 4 opposite, if this is 90 and that is also 90, it means 90 plus 90 must give you 180. Does it make sense? Yes. So therefore, A plus C must also give you 180. Then the two of them will give you what? 1, 2, 3, 4. All the 4 angles will sum up to 360 degrees. Does it make sense? So when you see a quadrilateral, whether it's a square, rectangle, trapezium, kite, rhombus, as much as it's a 4-sided, their sum inside the circle must be what? 360 degrees. And the two opposite must be so. Now this is a square or rectangle, right? So it's very direct. Let's look at this type, irregular shape like this. Okay, good, 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 good. You see? Therefore, this angle, so the angle A plus angle B must give you 180. A plus B equals 180 degrees. The two opposite must give you 180. Simple as ABC. This and that are also opposite. So maybe C and what? D. So angle C plus angle D, angle D must give you what? 180 degrees. It's not so simple. And the 4 of them, AB plus C, A, B, C, D, must give you 360. This is cyclic quadrilateral. So it's not always regular like you are seeing the rectangle or the square. It may look irregular, but as much as it's a 4-sided inside a circle, it is having that principle, the two opposites. So if you know one of the opposite and you find another way to get the second one, it's very easy. Add them and get 180. Good. Or equate to 180 and solve it. The other one will come. So there must be a way out to help you solve it. Good. A triangle can be drawn inside to help you get the other one. As you go along, solving questions, you apply. So as you see the properties, you apply them. You see them, you apply them. You see them, you apply. This property is a tangent, right? You know a tangent now. It touches the circle, it doesn't cross it. You know a tangent now. This is the center of the circle, right? So watch here. What angle is this? 90. Do you agree? Tangent coming from the center, meeting a radius from the center, right? This is also what? 90. So 90 plus 90 is 180. Do you agree? But these two angles, opposite angles, are different. They are not the same, but they must sum up to 180. Yes. This plus that must give you 180 degrees. It's having the same property of cyclic quadrilateral. This is a circle, right? And they connect to it. So 2 opposite equal to 180, and the 4 of them 360. So take me. Now, this when I draw this line, I get right angle triangle at opposite side. So I end up getting something like this. Here you can apply Pythagoras theorem. This is a 90 degree. Then if you have here and have there, or have one of them, Pythagorean triple principle or SOHCAHTOA, right? You apply SOHCAHTOA or the Pythagorean triple principle. So if you watch the video on trigonometry, you know what I'm talking about. Then you apply there. So there's no much. The last but not least property is also similar to that as we did earlier. So this is a tangent, that's a tangent. But the difference is that these lines are not coming from center. Yes, they are not coming from center. So you can see that this line can end here and come here. They are chord. This is a chord. This is also a chord. But if this line is equal to that line, there's a property they have to play. You get it? If I draw a line here, I get a triangle, but not right angle triangle, because this is not 90. Because this is not a radius. It's not coming from center. Therefore, it's not 90. But I get a triangle. And I'm sure it will be scaling triangle as we learn from angles. So that is what you have to recognize. Now let me talk about angles, circles quickly, triangles. There are four main types of triangles. Let me talk at them quickly, then we can answer some few questions for you to understand how to apply. Good. There are three main types of triangles. This is equilateral triangle. The mark is telling you that the angles are equal. So if the internal angle of a triangle is what? 180. That means if they are sharing equally, it should be what? 60, 60, 60. Do you agree? 60, 18, 180. So this is the mark to tell you. So the examiner talks about that equilateral triangle, 60, 60. So if the dimensions are 7, this 7, this 7, they are 7, 7, 7. If they are 10, 10, 10, 10, equilateral. The next type of triangle is equilateral comes from the word equity. So equal, right? Equilateral. The next one is isosceles triangle. So isosceles triangle, two sides and angles are equal. So if this is 50 degrees, that's also 50 degrees, right? What does it mean? What is left for them to? For the third one, this plus is what? 100. Therefore, here is what? 80 degrees. So always you put your fingers or your marks on this. The lines that are equal, you go down. As you go down, those are the lines having the equal angles. You get it? As you go down like this, these are the lines forming the equal. So it could be drawn like this way, this and that. So if I go down here, this is 50. I go down here, that is 50. Right? Now, in circuit theorem or any diagram question, you have every liberty to turn the paper as you want. You are paid for the paper. Take note. Then you are paid for the question paper. So you can turn the question paper upside down, left, right, you can turn it. So you see the picture you are expecting. There's a property you are expecting. You see a triangle. Check whether it's isosceles, equilateral, or scalene. Isosceles is very, very popular in your questions. So if you know the two sides, then so if you are given isosceles triangle and the examiner says these two sides and angles are equal, you can choose to represent them by the same variable. Maybe the third one is 30 degrees. So if you say x plus another x plus 30 degrees must give me 180. Internal angle sum to 180. Solve it. You get 2x equal to 180 minus 30. Then continue, your x will come. That becomes that angle. So that's isosceles. Two sides and angles are equal. That's the property. The next one is scalene. Scalene, all the angles and sides are different. You can see they are different. So if I say x, I say y, I say z, they are different. So they don't have anything in common. That's scalene. Scalene triangle. The last but not least is right angle triangle. Right angle triangle, one angle must be equal to 90 degrees. And this is the symbol you see. Or it will be drawn this manner. Yes, without the symbol. And you can tell that this is right angle triangle. That's very obvious to see. Good. If this side is taken or this angle is taken 90 degrees, what is left for them to share? They will share 90 degrees, the balance. If they decide to share it 45, 45 equally, it means this triangle tends to become isosceles because this line, 45, that line is also what? 45. So it tends to become isosceles. So therefore, isosceles triangle is a subset of right angle triangle. Do you get it? It's a typical objective question. Take note. Now, if they decide that they are not going to share it equally, this man takes 90, but there's Oga, there's a boss around. Okay, then the balance, the 90, I'm also the next person. So you can go here.